Experiment to investigate the effect of concentration on the rate of reaction. In this experiment, we will investigate the effect that the concentration of the chemicals taking part in a reaction has on the rate of reaction. We will react magnesium with different concentrations of hydrochloric acid. We will study the rate of reaction by collecting the hydrogen gas over water in a graduated cylinder as shown on the screen. The equation for the reaction is shown on the screen. Hydrogen gas is extremely flammable and forms an explosive mixture with air. No naked flames should be used in the laboratory. Using a graduated cylinder, place 50 centimeters cubed of 0.5 molar hydrochloric acid in a conical flask. You will need about 6 centimeters of magnesium ribbon in this experiment. This has a mass of approximately 0.07 grams. Set up the apparatus as shown on the screen. Use a 100 centimeters cubed graduated cylinder to collect the hydrogen gas. Add the magnesium metal to the acid. Immediately place the stopper on the flask and immediately start the stop clock. Give the conical flask a brief, gentle shake. At regular intervals, for example every 30 seconds, record the volume of hydrogen given off. Use a table similar to that shown on the screen. 30 seconds. 60 seconds. 90 seconds. 120 seconds. 150 seconds. 180 seconds. 210 seconds. When the reaction is over, note the final volume of hydrogen collected and then wash out the conical flask. Repeat the experiment using the same mass of magnesium metal but use 1 molar hydrochloric acid. That is, use acid having twice the concentration of the original acid. Ten seconds. 20 seconds. 30 seconds. 40 seconds. 50 seconds. 60 seconds. When the reaction is over, note the final volume of hydrogen collected and then wash out the conical flask. Record your results in a table similar to that shown on the screen. Repeat the experiment using the same mass of magnesium metal but use 1.5 molar hydrochloric acid. That is, use acid having 3 times the concentration of the original acid. Five seconds. 10 seconds. 15 seconds. 20 seconds. 25 seconds. When the reaction is over, note the final volume of hydrogen collected. Note that the reaction stops when all the magnesium metal has been used up. The magnesium is said to be the limiting reactant. This means that it determines or limits the volume of hydrogen formed. On the same sheet of graph paper, plot a graph of volume of hydrogen on the y-axis against time on the x-axis for each of the 3 concentrations of acid. A graph similar to that shown on the screen will be obtained. We conclude that the rate of reaction depends on concentration. The greater the concentration, the faster the rate. This concludes the experiment.